Before we go to page 12, I just want to make sure everybody got the answer down for 2. I think we found this right at the end of the video. And because we got the same answer, whether we plug the 9 in the first equation or the second equation, that means 0, 9 is our solution. So we don't have to do a check because I plugged it into both and got the same answer for both. So that's the same thing as doing a check. So save me a lot of time doing it that way, right? So once you get the first one, plug it into both. If the answer is the same, there's your check. Boom. 0, 9 is our point of intersection or our solution to the system. Okay, let's go ahead and move on to the next page. So solve the system using the addition method. If the system doesn't have a solution, state whether it's inconsistent or dependent and how many solutions. So, we have a decimal here. Don't like decimals, don't like fractions. So they're both already in standard form, but step 2 is get rid of decimals and fractions. So 1 decimal place, remember that's 1/10, 5/10, 8/10, which means common denominator's 10. And hopefully you remember from previous sections that just means move each decimal place over. So now I have 1x plus 5y equals 8. So nice whole numbers. And my other equation is 2x plus 6y equals 16. So they're both in standard form. No decimals or fractions are left, so step 3 is try to make opposites. So look at your x and y. Which one would be easiest to make opposites? So the first number 1 and 2 go into is 2. First number 5 and 6 go into is 30. So this would be much easier to keep this 2 and make this negative 2. So how do I make 1x negative 2? By multiplying by negative 2. And remember your arrows all the way across so you don't forget that last number. So making opposites means if this is 2x, this needs to be negative 2x. So I multiply by negative 2. And that leaves us with negative 2x, negative 10y, and negative 16. And the bottom row stays the same because we chose a variable that could be eliminated with just one multiplication. So negative 2x, negative 10y, negative 16. And then this one stays the same. So because I see that there's opposites, that means that I can add my addition sign and start adding. I can never add the two equations together until I have opposites, but I do. So remember, 2 minus 2 is 0. The x's have eliminated. So now I do negative 10 plus 6y, which is negative 4y, equals negative 16 plus 16, 0. Divide both sides by negative 4, and I get y equals 0. So then I can go right here and fill in my y, because I know my final answer has to be written as an ordered pair. So now I can go into either equation. I don't really want to go into a decimal equation, so I think it'd be easier to go here. So y is 0. So 2x plus 6 times 0 equals 16. That's gone. 2x equals 16. X equals 8. So like I said, it is kind of nice to plug it into both. So let's go ahead and put it into this one. That way I don't have to do a check. So now we're putting 0 in for this y. So we have to keep our decimals in for the check. So 0.1x plus 0.5 times 0 equals 0.8. So once I solve this, if I get the answer 8, I can go, woohoo! That means I got it right. So this time 0's gone. That's just 0. So I get 0.1x equals 0.8. Divide both sides by 0.1. And that's why I don't like leaving decimals in, because then you always have to grab your calculator, where if you have all whole numbers in it, you don't have to do that. There we go. Look at that. I got x equals 8 when I plugged into the second equation, x equals 8 on the first. Boom. That means I got this problem correct, because I got the same output each time I put 0 in for y. So that's kind of a fast, fun way to check it. Okay, now we're looking at some fractions. Woohoo, this is fun stuff. So next two problems have fractions. So with fractions, remember we have to find a common denominator for each equation to get rid of those fractions. So 3 and 2 both go into 6. So I put a 6 here, I put a 6 here, and I put a 6 here. Then I look at the bottom equation, and it can be a totally different number. The two equations aren't related. The first number that 4 and 2 go into is 4. So I can put a 4 here, I can put a 4 here, and I can put a 4 here. And then remember what I told you to do, either in your head or on your calculator? Multiply, then divide. Multiply, then divide. So 6 times 1 is 6, divided by 3 is 2x. No fraction left. Minus, so it's easy to lose a sign, so I try to do that first. 6 times 1 is 6, divided by 2 is 3y, equals 12. And remember, all the way across with that LCM, you can't skip any terms. Same thing with the denominator. So then we have 4x. 4 times 1 is 4, divided by 4 is 1y, or you could look at it like this. 4 divided by 4 is 1. 1 times 1 is 1y, and that's plus 1y. Plus 1y equals 20 divided by 2, 10. So now I have two nice, pretty equations. And either letter's easy to get rid of. If this is 4, I can easily turn that into -4. This is -3, I can easily turn that into 3. So there's not a better choice on this one. They're both easy. So let's do this one since they already have opposite signs. So since this is -3y, I need this to be positive 3y. So I'll multiply the second equation by 3. So first equation is going to stay the same, 2x minus 3y equals 12. And then this one's going to turn into 12x plus 3y equals 30. And then I look and say, have I achieved my goal? Did I make opposites? Boom. 3 minus 3 is 0. Ding, ding, ding. Gone. So 12x plus 3y equals 30. Now we're ready to add. 12 plus 2, 14x equals 42. Divide by 14. Divide by 14. X is 3. So all we have to do is find y now. So I don't know which equation's easier, to be honest. Let's go ahead and do the first one. We have our calculator, so we're not that worried about fractions, right? So I took the original problem, 1/3 x minus 1/2 y equals 2, because remember, you do have to check into the original problem. So I'm going to put 3 in for x. So 1/3 times 3 minus 1/2 y equals 2. And when you multiply reciprocals, you get 1. If you didn't know that, you could certainly figure it out. 1/3 times 3, so 1 fraction bar 3 times 3 is 1. So I have 1 minus 1/2 y equals 2. So subtract 1, subtract 1. So I get negative 1/2 y equals, when I subtracted 1, that's gone, and 2 minus 1 is 1. So now I have to do the opposite. The opposite of times negative 1/2 is divide by negative 1/2. And don't worry about it, you're doing it on the calculator, so we don't care how ugly it gets. So we're just going to type in 1. This is the division sign. Negative 1 fraction bar 2. So notice I counted this as division because it is division, and I did this one as a fraction bar because 1/2 is a fraction. This is not a fraction, it's a division bar because we divided both sides by negative 1/2. So it's 1 divided by the fraction negative 1/2, and that gives me negative 2. So see, when you have a calculator, things aren't so difficult, right? And let's go ahead and do this last one on page 12. So more fractions, but this time just with 1. So they all have the same denominator. Woohoo! That's nice. So we don't have any trouble picking a common denominator. It's just 2, right? 2 here, 2 here, 2 here. And guess what happens? Boom, boom, and boom. So they all cancel. That's the beauty of having the same denominator. So what does that leave? 1 times 1, which is 1x, plus 1 times 1, which is 1y, equals 7 times 1, which is 7. So that's a pretty little equation, right? Nicer than the original. 4x plus 4y equals 28. So this one, it's pretty much equally as easy to get the x or y to cancel. This is 4x. I can make this negative 4x by multiplying by negative 4. This is 4y. I can multiply by negative 4 to get that. So this one really doesn't matter. So either way, it's going to be negative 4. So the bottom equation stays the same. And the top one is going to get everything multiplied by negative 4. So it's going to turn into negative 4x minus 4y equals negative 28. And the bottom equation stays the same. And what do you notice? Look at that. Whoa, we've never seen one like that, have we? Gone, gone, gone. So if everything's gone, that means we have 0 equals 0. So, true or false? It's true, right? So guess what that means? Infinite solutions. And remember, infinite solutions means one line lies right on top of the other line. So we'll say on the line x plus y equals 7. I just took the ones out from the above. So infinite solutions on the line x plus y equals 7. And since one line graphs one right on top of the other, that means it depends on it, so this system is dependent.